Hello everybody, welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this class we are going to do some questions, some type of questions basically you must know before you move on to grade 10 specifically. So these are the some basic type of questions which they are used many a times in calculations. So it's not that specifically we are going to discuss those concepts over here, because anyways we are going to conduct Pratham series for grade 9 and Pioneer series for grade 10 from Monday. So basically over here it's a kind of trailer, the type of questions basically you must know. It's not that we are covering the every type of question over here in this specific session. I had also conducted one session that formulae and concepts which you must know before you move on to grade 10. So that thing was already done by me. This session is also an add-on session wherein we are going to do some questions on the basis of concepts which you must know, especially when you are going to grade 10. I mean, obviously you have already been to grade 10 because it's already 15th of April now. So I hope you guys are ready. Just confirm in the chat. Okay. So let's start with it, guys. So the very first thing which we will do over here is rationalization of denominator. So if suppose you have been given with this question x is equal to 2 by 3 plus root 7. So you have to find the value of x minus 3 the whole square. So you can directly put the value of x over here as well, but obviously you will not be able to get the answer very quickly. Hi Niharika, welcome to this session. So what we need to do over here is to do rationalization. So rationalization of the denominator is one of the things which you must know before you move on to grade 10. It is very important actually. So over here the value of x is what, guys? X is equal to 2 by 3 plus root 7 over here, right? So what we can do, we can rationalize the denominator. So you see this is 3 plus root 7 in the denominator. So can I multiply by 3 minus root 7 in the numerator as well as the denominator? That's how you rationalize the denominator of this type. I hope that is clear. Hello Lalita, welcome to this session. Hi Junior Indian Hacker. So I hope this is clear. So you see over here in the numerator we'll get 2 into 3 minus root 7, and in the denominator it is of the form a plus b, a minus b. So we can use a square minus b square identity. So it will give you 3 square minus root 7 the whole square, right? So this will come out to be equal to 2 into 3 minus root 7, and you see 3 3s are 9, and root 7 the whole square will be 7 over here, right? So basically what you are getting, guys, you are getting 2 into 3 minus root 7 and 2 in the denominator. So it will get cancelled out. So you see basically x is nothing but equal to 3 minus root 7. So you see, if you know how to rationalize the denominator, you can easily do questions of these types. So it is 3 minus root 7 over here. So you have to find the value of x minus 3 the whole square. So x is 3 minus root 7, minus 3 is already there, the whole square. So over here can I cancel out 3, guys? So the answer is equal to minus root 7 the whole square, and minus root 7 the whole square will be equal to 7 only. So this is the answer. So just comment in the chat, is the question clear to everybody over here? So these type of things will be there in grade 10 many a times, especially when you're preparing for some competitive examinations like NTSC, KVPY, something like that. Obviously apart from your school examinations, right? And in school examinations also these things can be used. So I hope it is clear. The answer over here is 7. So option 3rd is correct over here, right? So let's move on to the next thing, guys. So many a times you have to find the square root of something of this form. Square root of 8 plus 2 root 15. Can you try doing this and let me know the answer over here? Something called surds is used many a times. It's one of the basic things in mathematics which you must know before you move on to grade 10. Square root of 8 plus 2 root 15. So basically you have studied this property, guys, that square root of x square, that is equal to modulus of x, right? That is equal to modulus of x. It is not equal to x only. If you are writing equal to x only, so that is mathematically wrong. I'll explain one thing. For example, if you have got square root of 3 minus 2 the whole square, so that will be equal to 3 minus 2. So if you are saying that it is 2 minus 3, it is wrong, because this thing is negative. Square root can never give you a negative value. So therefore this thing is correct, this is not correct. I hope that is clear to you, right? So what you have to do over here, you have to fix the thing inside this square root in the form of a perfect square. Basically you have to complete the square over here, right? Completing this square thing you have to use. So you see over here, this square root is what? You see this thing first. 2 root 15. What is that equal to? Can I say it is 2 into root 5 into root 3? Can I write it like this? 2 into root 5 into root 3, right? Now you want 8 over here. Now you see, can I write 8 as root 5 the whole square plus root 3 the whole square? Can we do that, guys? Why we are doing it actually? Because you see, root 5 the whole square is 5, root 3 the whole square is 3. So that is 5 plus 3, that is equal to 8. And why we are doing it? Because it is of the form a square plus b square plus 2ab over here. I hope that is clear. So you see, this thing will be inside this square root. It is nothing but square root of 5 plus square root of 3 the whole square. So you see, this is already positive. So this will come out to be equal to square root of 5 plus square root of 3. So this is the answer. So finding square roots of surds, this is one of the things which is used many a times, especially when you are preparing for competitive exams like NTSE and KVPY. I hope this is clear to every student over here. Okay, so let's move on to the next thing. We'll do a similar type of question. So x is given to be equal to square root of 7 plus 4 root 3. Then you have to find the value of x plus 1 by x over here. X plus 1 by x. So for that, what you have to do over here, guys? Exactly, you have to first simplify the square root. You see, so this is nothing but square root of, you see, 4 over here. So can I not say that it is 2 into root 3? 4 root 3 can be written like this. Now you will say, why we are writing like this? We are writing it like this so as to fix it in the identity a plus b the whole square. So 2 into root 3. So can I say that this is 2 and this is root 3 and we want 7 over here. So can I write 7 as 2 square plus root 3 square? Can we do that, guys? So you see, this is 2 square is 4, root 3 square is 3. So 4 plus 3 is 7. So it is coming of the form a square plus b square plus 2ab. So what we will get inside this square root, we will get square root of 2 plus root 3 the whole square. Now you see, this is already positive, so we don't have to bother about its sign after you take it out of the square root. So can we say this is nothing but equal to 2 plus root 3. So this is equal to 2 plus root 3. Okay, we'll do that, Junior Indian Hacker, no problem, I'll do that. So we have got 2 plus root 3 over here. Just concentrate on this question first. Now you see, x is equal to 2 plus root 3. I want the value of 1 by x as well. So 1 by x is what? It is 1 by 2 plus root 3 over here, right? So what I can do? I can rationalize the denominator. So I can multiply and divide by 2 minus root 3. Yes or no? 2 minus root 3 I can do over here. So this is basically 2 minus root 3, and in the denominator you are having a plus b, a minus b form, right? That's how you rationalize the denominator. So it is a square minus b square in the denominator. Now you see, 2 square is 4, root 3 square is 3. So 4 minus 3 is 1 only. So 1 by x is 2 minus root 3 over here. I hope this is clear. Now you want the value of x plus 1 by x. So let's do over here, x plus 1 by x is what? X we have got to be equal to 2 plus root 3, and 1 by x we have got to be equal to 2 minus root 3. So I can cancel out root 3. So therefore the answer is coming out to be equal to 4. X plus 1 by x is coming out to be equal to 4. So any doubt in this thing? Can you confirm that? That's what I was saying, Nashit. I'll explain that using one more example, don't bother. Is it clear? So again I'm explaining this thing. See, if it is not clear, I'll explain once again. Just see over here, guys. So basically it is square root of 7 plus 4 root 3. So what I will try to do, I will try to fix the thing inside the square root as a square of something, because then only you can remove the outer square root, right? So you see it is 4 root 3. Can I say it is 2 into root 3? 2 into 2 into root 3. Now can I write 7 over here? This 7 can be written as 2 square plus root 3 the whole square, yes or no? Because 2 square is 4 and root 3 square is 3. So is it of the form a square plus b square plus 2ab inside the square root, guys? So it will give you a plus b the whole square or not? Tell me. So you see this is square root of a plus b the whole square. So this will come out of the square root. 2 plus root 3 will come out of the square root, right? Now we want the value of x plus 1 by x. So x is equal to 2 plus root 3. It means we want the value of 1 by x as well. Now 1 by x is 1 by 2 plus root 3. So we have to rationalize the denominator over here by multiplying and dividing by 2 minus root 3. So in the denominator it is of the form a plus b, a minus b. So it will be a square minus b square. Now 2 square is 4, root 3 square is 3. So in the denominator 2 minus 3, 1 is there. So basically 1 by x is coming out to be equal to 2 minus root 3. Now you know the value of x, you know the value of 1 by x. You can put it over here, root 3 will get cancelled out, 4 is the answer. Is it clear to every student over here? I hope it is clear. Niharika, Nasheet, Junior Indian Hacker. The previous question was same, only Junior Indian Hacker. I mean, in fact, this is more advanced than the previous question. Is it clear now? Just confirm in the chat. Okay, now one more thing I am saying, suppose if that is your query, I will explain that thing again. Suppose you have got inside the square root, you are having something like this, 2 minus root 3 the whole square, something like this, and you will say that 2 minus 3 is the answer. No, that is wrong, because a square root can never give you a negative value. Therefore, I had explained that in the previous slide, that square root of x square is equal to modulus of x. It is not equal to x over here, right? So therefore, this will not give you 2 minus 3 the whole square. You have to manipulate it. Basically, it will be coming out to be equal to modulus of 2 minus 3, right? And modulus of 2 minus 3 will be modulus of minus 1 and it will be plus 1, right? I hope that is clear now. Okay, yes, please ask. I hope it is clear now. Yes. Nasheet. Okay, Junior Indian Hacker. Now one more type of important thing which is used many a times in calculations, maybe by that name it is not used in grade 9 and 10. If you talk about your school examination, your board syllabus, but when you study for NTSE and all that, and when you move on to higher classes, something called partial fractions is used, right? Partial fractions. So basically what you have to do, see, it is 1 by x plus 1 into x minus 1. So you have to break it down like this. So many a times you will get something like this and it will help you simplify expressions very easily. Only Hindi is not possible because there are many students, Junior Indian Hacker, who are from South India, so they will not be able to understand. I hope समझ रहे हो तुम. देखो मुझे कोई problem नहीं है, but obviously I have to work according to everybody, right? I hope that is clear. So something called partial fractions we have to use over here. Again I am saying we are not doing the complete thing. ऐसा नहीं है कि इसी एक क्लास में मैं सारा पार्शियल फ्रैक्शन तुम्हें बताने वाला हूं. It is not like that. From Monday onwards, obviously we are going to do the things, Pratham series for grade 9 students and Pioneer series for grade 10 students, right? So we are going to do that. We have already launched that. This is just a trailer session, you can say, right? Okay, fine. So over here, partial fraction you have to understand. So you see, when you have got linear factors in the denominator, this is linear. You understand, linear, highest exponent of the variable is 1. Yes or no? So this is the linear factor over here. This is also linear. So every time it can be opened up like this, a by x plus 1 plus b by x minus 2 over here. It means for a linear factor only a constant can come up. For a linear factor only a constant can come up. For a quadratic factor, a linear factor can come up. For example, I'll take an example over here. For example, it is something like this. I'm not going in the detail of this thing because we are not doing that right now. So you see, this is a quadratic factor. 2-degree polynomial over here. So it will have a linear factor ax plus c divided by x square plus 1. Again this is linear, so it will have only constant. You got it? It means in the numerator you will every time get something of 1 degree lower. If it is quadratic, it will give you linear, it is a linear, so it will give you constant. I hope that is clear. So this is called partial fraction. Obviously this we cannot do right now in this one session. I hope it is clear, right? So over here you just have to understand that these are linear factors, so only constants will come up over here. So you have to find the values of a and b, that's it. So what I can do, guys, I can just take LCM and simplify. So I'll get a into x minus 2 plus b into x plus 1, something like that. That's how you take the LCM, right? And in the denominator it is x plus 1 into x minus 2. I hope that is clear. So what you see, this thing and this thing, they are same in the denominator, so they will be cancelled out, right? So you can equate the numerators over here. So you'll get a is equal to 1 is equal to a into x minus 2 plus b into x plus 1, something like this. I hope that is clear. Now let's simplify, let's combine these things. So this is a plus b into x, I can say. You see, a plus b into x minus 2a plus b, right? Now you see, if you compare both the sides of this equation, in the left hand side you don't have linear term, you don't have a term called x over here, I mean having x over here. So what I can say that a plus b is equal to 0 or not? Coefficient of x is coming out to be equal to 0, and you see constant term minus 2a plus b is equal to 1 only. So minus 2a plus b is equal to 1 only over here. I hope that is clear after comparison. So what we have to do, we just have to solve these equations for a and b. Pair of linear equations in two variables, we have to solve for a and b over here. So how we can solve? Suppose I can subtract the first equation from the second equation. So what will I get? I'll get 2a plus b minus a minus b, that is equal to 1. So this will get cancelled out. So from here I'll get minus 3a, that is equal to 1. So basically a will come out to be equal to minus 1 by 3. So a is coming out to be equal to minus 1 by 3. Now can I use this equation, guys? B is what? B is equal to minus a. So a is minus 1 by 3. So b is minus of minus 1 by 3. So it is 1 by 3. So you see, a is equal to minus 1 by 3 and b is equal to 1 by 3 we have got. So just compare over here. For x plus 1 it is a, for x plus 1 you see. So a is coming out to be equal to minus 1 by 3 and b is coming out to be 1 by 3 over here. So therefore first option is correct. Is it clear to everybody? Just confirm in the chat. So this is a type of thing called partial fractions. This is one of the basic partial fractions, and many a times it will help you solve questions quickly, especially in progressions which you will learn, AP and all that, something called telescopic series. It will help you to simplify them. So don't get scared by names. It is not, I mean, anything exotic, right? I hope it is clear to everybody over here. So we'll take one more question on partial fractions over here. So again you see, it is x minus 1 and x minus 2. You just have to see the factors in the denominator. So they are linear factors, right? So if they are linear factors, so they will have constants only in the numerator. You see, they will have constants only in the numerator. I hope that is clear. Now there is one more trick of solving partial fractions. I'll explain that. So I can simplify this, a into x minus 2 plus b into x minus 1 over here. And in the denominator we have got x minus 1 into x minus 2. So what I can do, I can cancel out this, right? So if you compare on both the sides, I'll get 2x plus 5, that is equal to a into x minus 2 plus b into x minus 1, right? Now in the previous slide we have studied how to find the values of a and b by comparing and forming a pair of linear equations in two variables, right, over here. Now that can be done over here as well, but there is one more trick of doing that. It will save your time. What we can do, I want the value of a, right? Now what is the 0 of this polynomial? For what value of x this will become 0? Tell me. For what value of x this will become 0? X is equal to 1. So I can put x is equal to 1 on both these sides of this equation. So let's put x is equal to 1 over here. So that can be done in the left hand side, in the right hand side as well. So you see 1 minus 2. If you put x is equal to 1, this will become 0. So you can easily find the value of a. So a will come out to be equal to, see, this is minus 1, this is 7, so minus 7. So a is coming out to be minus 7. Now you want to find the value of b. So what will you do? You will put x is equal to 2 because you will remove it when you want b over here. The 0 of this polynomial you will have to put in the equation over here. So let's put x is equal to 2 over here. So if I put x is equal to 2 on both these sides of this equation, so you see 2 into 2 plus 5, that is equal to, over here if you will put 2, this will nullify, I mean this will vanish, right? So this will be b into 2 minus 1. So if you simplify, what is the value of b, guys? B is coming out to be equal to 9. I hope it is clear. So you see a is minus 7, b is 9. That is the answer. So in place of, you see, minus 7 upon x minus 1 must come. Minus 7 upon x minus 1 and b is 9. So 9 upon x minus 2. This is the answer. If you will simplify this thing, you see you will get that only. I hope that is clear. So it is very important, one of the important things which will save your time for sure. Something called partial fractions. Is it clear to everybody over here? This is the different trick by which you can solve partial fractions quickly. Again I am saying that we are not doing partial fractions as a whole. We are just taking basics of partial fractions, right? Obviously in one session it is not possible, and you don't need to know it either, right? Many a times that is not needed. That will be needed when you move on to grade 11 and all that, like integration and all that, that will it is needed there. I hope it is clear. Now one more thing which is important when you move on to grade 9 or 10, you know that surface areas and volumes formulae must be on your tips. You cannot say that I don't remember how to find the total surface areas and volumes and lateral surface area of cube, cuboid, cylinder, cone and all that. These things must be on your tips. It will come with your practice only. And obviously in case of circles as well, sector, segment, minor sector, minor segment, right? Minor arc, major arc, these things must be on your tips. So 2 questions I am taking over here just to remind you that these things must be on your tips, and it will come with practice only. It is, see, no one trick will work everywhere. This was a trick only, Junior Indian Hacker. This was a trick only to solve partial fractions quickly. You cannot say that you will not practice enough number of questions and then you will be able to do something quickly. Believe me, it is the ultimate truth. It can never happen. There is no trick. You have to practice the trick as well. You got it or not? Suppose you know some short form, some short trick to do something quickly, then also you have to practice it. You cannot say that I'll not practice but I'll be good at that. It can never happen. It never happens in anything in your life. It's not just about mathematics. It's about anything which you go through in your life. I hope it is okay with you. Right? So let's do a question. Area of a sector of a circle of radius 36 centimeter is 54 pi centimeter square. Find the length of the corresponding arc of the sector. Can you do this question? You have studied this formula in grade 7, grade 8. If you are moving to grade 10, then you must have studied in grade 9 as well. So can you try doing this one and let me know the answer over here? What is the area of a sector of a circle of radius 36 centimeter is 54 pi centimeter square? Find the length of the corresponding arc of the sector. So you see there is a formula basically. Area of the sector, if you know that, you see this is a circle, and if a chord or if an arc is subtending theta angles at the center, and suppose its radius is r, suppose area of this sector is a. This is sector, guys. Area of this sector is a, and length is the length of the corresponding arc is L, right? So area of the sector is what, guys? Area of the sector A over here is theta by 360 into pi r square. You know this formula? Theta by 360 into pi r square, right? Now over here we can do a bit of manipulation. You'll learn something. You see, can I say this is theta by 360 into 2 pi r into r by 2. Can I write like this? You see, in place of r square I have written r into r, and 1 2 I had taken over here, then obviously I have to divide by 1 2 as well. Now what is this? Theta by 360 into 2 pi r is the length of the corresponding arc or not? So this is L or not? Tell me. Into r by 2. So this is a formula which will help you to do questions quickly many a times, especially in objective examinations. That area of a sector is equal to length of the corresponding arc into radius by 2. A is equal to LR by 2. I hope that is okay with you. A is equal to LR by 2 must be on your tips. Now over here you see area of the sector is given, length of the radius is given. So let us put it over here. Area of the sector is 54 pi centimeter square and radius is 36 centimeter. You have to find the length of the corresponding arc by 2 over here. So you see this is 18 and this is 3. So length of the corresponding arc is coming out to be 3 pi centimeter. That is centimeter only, right? So you see this formula, one of the important formula. I'm not saying this is the most important formula which you will see. This is just a trailer. Obviously we are going to do everything in detail from Monday on the Infinity Learn class 9 and 10 YouTube channel. If you haven't subscribed it up till now, please do subscribe and please don't forget to hit the bell icon. And also one more thing, in the description you will get the link of the Telegram channel. Please subscribe to the Telegram channel as well. I hope it is clear up till here that A is equal to LR by 2 is an important formula, and I hope the derivation of the formula is also clear to you. So let's do one more question. Just try to do this over here. A semicircle of diameter 1 unit over here sits at the top of a semicircle of diameter 2 units. So basically two semicircles are here. You see one semicircle is this, the smaller semicircle. This is on the top of the bigger semicircle. This is the bigger semicircle, right? Of diameter 2 units. Now the shaded region inside the smaller semicircle but outside the larger semicircle is called a lune. This is a name which you must know. It's called a lune. I mean, nobody is going to ask this thing in the examination. Okay, Junior Indian Hacker. Obviously, nobody is going to ask this thing lune in the school examination because it is not there in your NCERT syllabus, but you must know the terminology over here. This is the lune, the region between the smaller semicircle which is outside the bigger semicircle. So that is called a lune. So we have to find the area of the lune over here, right? So for that we have to find the area of the segment, for which you will understand it quickly. See, so what I can do first, can you join the center of the larger semicircle like this? Center of the larger semicircle I can join like this. I hope that is clear. Now you see in this question it is already given that the diameter of the larger semicircle is 2. So its radius will be 1 or not? Tell me. This will be 1 unit, this is also 1 unit. So this will also be 1 unit and this will also be 1 unit, right? Because these are radii of the larger semicircle or not. So what is happening over here, guys? That this region, suppose I am naming it ABC, this is coming out to be an equilateral triangle or not? Because all these sides are of equal lengths. ABC is coming out to be an equilateral triangle. Its sides are of equal lengths over here. I hope that is clear. Now you see over here what we need to do. Suppose in this case, suppose I am naming this region, suppose I am naming the area of this region as X, this small region. This area I am naming as X. Just see it very patiently. This is one of the good questions you will get, right? Now what is X over here? Just see. What is X over there? It will be the area of this sector. You see this is a sector or not? Area of this sector whose central angle is 60, because area of each angle of an equilateral triangle is 60 degrees. So ABC is an equilateral triangle, we have already proved. So therefore this angle will be 60. So area of this X over here will be what? Suppose this point is D. This is D. So area of X over here will be area ABCD. area of sector ABCD minus area of triangle ABC over here. I hope that is clear. Now you see central angle of that sector, this is 60 over here, and area of a sector is what? Theta by 360 into pi r square. So 60 by 360 into pi r square. R is 1 over here. Now area of an equilateral triangle, ABC is an equilateral triangle, so its area is root 3 by 4 side square. You have studied this formula, root 3 by 4 side square over here. I hope that is clear. So you see this is 60 into 6, 36 over here. So therefore this is pi by 6 minus root 3 by 4 centimeter square. That is not centimeter, it is square units. I hope that is clear. So this is the area of the region X over here. This area we have got to be equal to pi by 6 minus root 3 by 4 square units. But that is not being asked in the question. We have to find the area of this region, this shaded portion called lune over here. So how do we find it? So area of the lune over here is the area of the smaller semicircle, minus x or not. You see that. So area of the smaller semicircle is what? Pi by 2. Radius of the smaller circle is, diameter is 1, so radius is 1 by 2. So pi by 2 into r square minus area of region X we have got over here. So that is pi by 6 minus root 3 by 4 and obviously square units over here. So that is the answer. Let us simplify it. So basically this is pi by 8 over here, pi by 8 open the bracket minus pi by 6 plus root 3 by 4 square units. So this is the answer over here. Let us simplify it first. So pi by 8 minus pi by 6 is what, guys? So this will give you minus pi by 24. So basically the area of the lune over here is coming out to be equal to root 3 by 4 minus pi by 24 square units. So this is the area of this lune, and this is a previous year question of KVPY. That I have already done, Niharika. Please check the Infinity Learn class 9 and 10 YouTube channel. 3-4 videos back you will see that important formulae and concepts which you must know before moving to grade 10. I had already discussed them. So please see that, okay? And from Monday we are going to start complete series for class 9, that is Pratham series, and for grade 10 students called Pioneer series, where we will cover CBSE as well as questions from NTSE and KVPY as well. Okay, so that's all we needed to discuss in this session. Don't forget to like, share and subscribe. Bye bye guys, take care everybody.